Welcome to the 15th lecture. We are studying basic electrical engineering. In last lecture, we started studying superposition theorem and solved an example. Before we solve another example here, we first review the basic concepts or the steps to perform the superposition theorem. The first step is that we'll work with one source at a time. We may have multiple sources in the circuit, but when we apply superposition theorem, we work with only one source at a time. All remaining sources are replaced with their equivalent resistances. All voltage sources are replaced with their equivalent resistance. The equivalent resistance of a voltage source is very small. Therefore, voltage sources are replaced with short circuits. Current sources, internal resistance of a current source is very large. Therefore, current sources are replaced with open circuits. And we solve with one source at a time. Once we have completed this solution, we'll have many component solutions because we'll have many component outputs which are output voltage or current, which we finally add to get the final output. In our last lecture, we analyzed a circuit that had two voltage sources and we worked with one voltage source at a time, and then we finally added the outputs computed that we obtained by keeping one source at a time. Here we have two sources. One of them is a voltage source, the other is a current source. We'll keep one source and we'll replace the other source with its equivalent resistance. Let's keep this 12 volt voltage source first and replace this 4 milliampere current source with its equivalent resistance. So, keeping volt source. If we keep this 12 volt source, we have to replace this 4 milliampere current source with its equivalent resistance, that is open circuit, infinite, and we'll replace it with open circuit. Once done, now we have only one loop with one voltage source 12 volt, and we are asked to find voltage drop across this 2 kilo ohm resistor. We'll call this V out prime because it's a component solution, a part of a solution. So if we add these two series resistors, they become 2 kilo. This is also 2 kilo. So this 12 volt source, according to voltage divider theorem, is 2 over this 2 plus 2 times 12. So one component solution is 6 volts. But it's not the final answer. Now we have to work with the other source, the 4 milliampere current source, and we'll replace this 12 volt source with its equivalent resistance. So let's get that source back. And replace this 12 volt source with its equivalent resistance, short circuit. Now at this point, this 4 milliampere current divides, and part of it flows through 1 kilo ohm branch, part of it flows through this 1k plus 2k 3 kilo ohm branch. So since we are interested in the voltage drop across 2 kilo ohm resistor, we are interested in this current. So let's call this current, the current in this branch, let's call it I out, and this as V dual prime. Let's apply current divider theorem. This 4 milliampere current divides between these two branches. Since we are interested in I naught, the current that flows through this 3 kilo ohm branch, we'll keep this 1 kilo ohm in the numerator, the sum of the two in denominator times the total current 4 milli. So we get 1 milli. We get I naught is equal to 1 milli. And this 1 milliampere current flow flows through this 1 kilo ohm and 2 kilo ohm resistors. So according to Ohm's law, V out dual prime is 2k times the current flowing through it, which is I naught. 2k times 1 milli. So V out dual prime is 2 volts. So now we have two component solutions, V out prime, V out dual prime. Keeping 12-volt source, and this was done by keeping 4 milliampere source. So now we can finally add the two to get the final output. 6 plus 2 is equal to 8 volts. In my notes, I have verified this answer V out by another technique, the nodal analysis. I have applied nodal analysis to the same circuit, and we come to know that we reach the same answer V out. So we refer to the notes to get this answer verified using another technique. In the next lecture onwards, we'll study other circuit analysis techniques like Thevenin's theorem and Norton's theorem. Thank you.